Alright, hello everyone. So it's pretty early in the morning and I am at home and I'm doing these notes for you guys. So if you do hear noise in the background, it's just people who are getting in and out of the house or trying to go through a different room. So do not mind the background noise. But today I'm going to be going over the notes for shapes of distributions, which is our last lesson of our statistics unit. Yay! Okay, and this one's a pretty easy one. We're just going to be looking at the shapes of distributions of dot plots and histograms, because in statistics, we're not just looking for mean, median, mode, and looking for averages and looking for those kinds of things. We can look at graphs like dot plots and histograms, and we can see where the data is more skewed to. Okay, so dot plots, let me grab my notes here. Okay, dot plots, you know what they are, and histograms, which we learned at the beginning of our unit, can be used to identify shapes of distributions. Okay, so key ideas. So you see this first graph right here. You notice that there's a line going through it, and then this part is labeled the tail because it's the thinner part of the data. It's where the data starts to lower, where it starts to go down. So we call that the tail end. Okay, so a graph like this, a histogram that is like this, or a bar graph like this, is going to be skewed left. And here's why. The tail, which is this part right here, this guy, of the graph, extends to the left, meaning it's going to the left, and that's exactly what it's doing. The tail is extending to the left of the graph, not to the right, but the left. Okay, and most data are on the right, meaning, see how most of the data falls on the right side of the graph? So if most of the data falls on the right side of the graph and the tail extends to the left, that means that the graph is skewed left. Okay, and just a quick note, wherever the tail extends to, whatever side the tail extends to, that's a quick way to tell which way it's skewed, if it's skewed to the left or to the right. Okay, so this is a skewed left graph. Now for this guy right here, you'll notice that it makes a big hill. Okay, there's technically two tails, and then it meets at a point here. So just looking at this graph, and you see that it goes up and then it goes down, and it looks the same on both sides. If we were to fold this in half, each side of the graph looks the same. So meaning that this graph is symmetric. And you know what symmetric means? Symmetric is, if you remember in grade school, when you do symmetric, it means that both sides are the same. It's a mirror image. Okay, so the left side of the graph is a mirror image of the right side of the graph. Okay, so we know that, and that really loud noise is the garbage truck outside. Okay, so you know that's how early this video was being made. Okay, so the left side of the graph is a mirror image of the right side of the graph. So this is the left side, this is the right side, and they both look the same. They're mirror images of each other. Okay, so that's a symmetric graph. So if you see that the left side and the right side of a graph are mirror images of each other, then that's how you know it's a symmetric, that it's a symmetric distribution. Okay, now for this guy, finally at the end. So remember at the top we saw that it was skewed left, the tail was going to the left side. If you look at this guy right here, the tail is going to the right. So based on, if you know that skewed left, if the tail is going to the left side, this is going to be skewed right. Okay, so the tail, again, where the data starts to get smaller, that's the tail of the graph, extends to the right. And this is your right side. Okay, this is the right. Oh, wait, no, that looks terrible. Okay, this is the right, this is the left, right, left, right, left. Okay, Okay, most data are on the left. So if you look at this graph, you see that most of the data falls on the left side of the graph, okay? Because the graphs are getting higher, there's more data that's being represented on the left side of the graph, okay? So,